Hello and welcome to Chapter 7. So Chapter 7 hopefully is going to be a little bit of a review for you. We're going to talk about laws of sines and cosines, which I know that you've seen in geometry. And so hopefully this is a nice little refresher for us. Okay, so the first thing we're going to start talking about is that we've only really worked with right triangles, right? We have to have a right triangle in order to use Pythagorean theorem. Our SOHCAHTOA, our unit circle is all revolved around right triangles. So now we're going to talk about what if we don't have a right triangle, okay? So an oblique triangle is what we call a triangle that does not have a right angle. Okay, so if a triangle does not have a right angle, it can either be acute or maybe even obtuse. Okay, remember acute has angles that are less than 90 degrees, and obtuse has one angle that is between 90 and 180. Okay, so we have triangles that could be right, or we have triangles that are oblique, meaning no right angle. Okay, and these would fall into the categories of acute or obtuse. Okay, so back when we talked about triangles in geometry and even throughout this class, we've associated the side and the opposite angle kind of as a pair that go hand in hand, right? The smallest angle is opposite the smallest side. The largest side is opposite the largest angle. Okay, kind of similar. We've always used like capital A as our angle and little a as our side, or capital B and little b, capital C and little c. Okay, so now we're going to change it up a little bit, and we're going to now bring it all back to our Greek lettering, right? We've been talking about theta this whole semester. So now instead of A, we're now going to use the symbol. It's kind of hard to see. It looks like a sideways, like almost like one of those fish, but without the closing of the fin. Okay, so this is alpha. Okay, it's going to be opposite of side A, lowercase a. Okay, and then we have beta. Okay, this one's a little easier because it looks like a B. It just has it kind of extended down the one side. That's opposite of little b. And then we have this symbol called gamma. It's kind of like a little twisty thing. So kind of like alpha flipped up a little bit. Obviously, we're not going to draw these perfectly the way that they are written in Greek, but as long as we get the right idea. But gamma is going to go with little c. Okay, so alpha little a, beta little b, and gamma little c. So as always, it's important to remember that our three angles of any triangle add up to 180. That is never going to change. Okay, that says that again right here. The sum of all three angles must equal 180. What else do we have? So our goal here is we want to find the lengths of all three sides and all three angles. Okay, so in this scenario, we're going to talk about different cases. Okay, you have seen these in geometry. You might not have seen them for a while, okay? But we talked about these when we did congruent triangles, when we tried to prove that one triangle is congruent to another. So one case is when we have one side and two angles. We could see this in angle, angle, side, or angle, side, angle. So those are very similar because they both have two A's and an S. The only difference is the location of the S in reference to the A's, right? An angle, angle, side, the S is on the outside. So notice the side that we see is outside of those two arcs that we know, outside of the two angles. Similarly, but a little different, angle, side, angle, that side that we know is sitting nicely in between the two arcs. That's why the S is located in between the two A's. Okay, another case that we have is where we have two sides and the angle opposite of them. Okay, so we did not see this one in geometry because this one in reverse spells a bad word. Right, so we didn't use this one, but it is a scenario that we could use in this section to potentially find the rest of the pieces of the triangle. Okay, one that you did see in geometry is two sides and the angle between them. Okay, we saw this as side angle side. Notice the angle here is sandwiched in between the two sides that we know. Okay, and then we also have case 4 where we have three sides, meaning that we know all three sides of the triangle. Okay, so one of the equations that we've used in geometry to kind of help us if we don't have a right triangle, right? If we don't have a right triangle, we cannot use Pythagorean theorem, we cannot use our SOHCAHTOA, so then we're kind of at a loss. And this is when we start to use maybe our law of sines. Okay, so this is our equation, right? Notice that this ratio, the sine of the angle is on top of the side that it is associated with, that it is across from. Remember when we use these laws of sines, you can only set up a ratio and solve a ratio that has two sides. So we're only going to have enough information to maybe fill in two of them, and then we're going to solve from there. Okay, so let's do an example and remind ourselves how to use this. Okay, so here's our first triangle. It already has everything labeled. Okay, one of the things that I like to do is I like to kind of color code these, kind of match them up so we make sure where our pairs are coming from, because there's kind of a lot going on. Okay, so we have our alpha here is 105 and little a across from it. We have beta is 43 and little b is 30. And last but not least, we don't have little c and we don't have gamma. Okay, so in order to find and use law of sines, we need to have a pair. So that's where it's super convenient to do this color coding, because then you can figure out like, okay, do we have both blue pairs? Or do we have the yellow pair? Or do we have the pink pair? So the pair that we definitely have is that pink pair. So that's the side that we definitely want to use to maybe find something else. Okay, so if we're going to use the pink pair, we definitely need to have the sine of beta, which is 43, over the opposite side, little b, which is 30. Okay, the only other thing that we know here is alpha, so we probably want to start there and do the sine of 105 and find little a. Okay, when we have our ratio, right, we only have two sides, so we're not worried about gamma and little c yet. We're just worried about these two sides that we have. In order to solve a ratio, we cross multiply. Okay, so we'd have a times the sine of 43 equals 30 times the sine of 105. Okay, if you want, you can go ahead and type in 30 times the sine of 105, making sure that your calculator is in degree mode. I would probably hold off on it just to make sure that we're not rounding anything. It's best if we wait till the end to plug this in our calculator. So the last thing we want to do is divide by the sine of 43. So we would have a equals 30 times the sine of 105 over the sine of 43. Okay, and you want to put that in your calculator just like it says, okay? I would recommend doing your alpha y equals, get your fraction, and type in 30 times the sine of 105 over sine of 43, making sure that your calculator again is in degree mode, and you should get that a is equal to 42.49. So we can go ahead and label that if we want. Okay. So then from here, we still need to find little c and gamma. We can't use the law of sines yet because we don't have one of those. So luckily, we can find what gamma is because we know two angles of the triangle, right? If we know two angles of the triangle, we can always find the third because they should equal up to 180. So if we subtract what we know, we should find that gamma is equal to 32. Okay, so now that we know that gamma is equal to 32, now we can find little c. So we want to take the sine of gamma, which is 32, over little c. And from here, we could use either the yellow pair or the pink pair. I would probably recommend using the pink pair just because nothing has been rounded in that set. So sine of 43 over 30. Okay, again, we only have one unknown, which is great. And we want to go ahead and cross multiply. So c times the sine of 43 equals 30 times the sine of 32. And then divide by the sine of 43. 30 times the sine of 32 all over the sine of 43. Go ahead and put that all in your calculator and you should come out to 23.31. Alright, and then we can go ahead and label that. C is equal to 23.31. And therefore we've successfully solved the triangle because we were able to solve all of the side lengths and again all of the angle measurements. Okay, so the next one I'm going to go ahead and skip just for the sake of this video not being super long. It's set up the same way as the other one, okay? If you wanted to go ahead and try it just so you can kind of get your feet wet, I'll go ahead and tell you the answers. So alpha ends up being 35. Little b ends up being 20.84. And little c ends up being 18.12. Okay, the next one is solved slightly differently, so I want to make sure that we're all on the same page with labeling one and solving this one. Okay, so we have that alpha here is 133. That's a really big angle, so let's put that at this large angle here. Okay, remember alpha is opposite of little a, which is 48. And then we have little c is 17. You can really just pick whatever you want that to be. So maybe we'll put beta up here and little b. And then we'll say gamma is here. And then little c here is 17. Okay, so if we want to go ahead and color code these, I'll do an alpha. Again, it doesn't matter the color if you want to color code them differently. I just really want to show you the start of this one, and then you can go ahead and finish it on your own. Okay, so for this one, our pair here is the yellow set, right? We have alpha and we have a. So we definitely want to take the sine of 133 and then over little a, which is 48. Okay, from here, we don't have anything to do with beta and little b, so we probably want to leave that for later on. But we do have little c, so maybe we can figure out what gamma is because we know that little c is 17. Okay, so we have enough in our setup where we only have one variable, which is good. Okay, with any of these, once you get them set up, you're going to cross multiply. So we have 48 times the sine of gamma equals 17 times the sine of 133. And I forgot to mention in the first one, if you have them the other way, like the sine of gamma over 17 equals the sine of 133 over 48, that means the same exact thing. Remember, we can have an equal sign. An equation can be backwards like that. Okay, again, with the cross multiplying, it can be the other way as well. So we need to get gamma by itself. So the first thing we need to get rid of is the 48. So we're going to take the sine of gamma is 17 times the sine of 133 all over 48. Okay, so this is great. We have everything basically by, like, we have gamma by itself. We just are forgetting the sign. So if you remember from chapter 6 when we were talking about all of our inverses, right? In order to get sine or cosine or tangent away from our unknown angle, we can do the inverse. Okay, so this is going to look really complicated probably at first, but it's really just going to be put into our calculator. So when we take the inverse sine of both sides, we get gamma by itself, and then we're going to take the inverse sine of this entire thing. Again, I would recommend waiting until the end here to put anything in our calculator just so that nothing is rounded, and that way we can get the most accurate answer we can. So if you put this in your calculator exactly like it says, remember to get to the inverse, you hit that blue second key and then the sign button. I would recommend putting this in just like your fraction. Hit your green alpha button and y equals. Enter will give you that fraction. 17 times the sine of 133 and then 48 on the bottom. You should get that gamma is about 15.01. 15.01 would be our answer there. Okay. So I just wanted to show you that way because when your unknown is inside the sign, you have to remember to use that inverse. So from here, I trust that you can complete the rest of the problem. Let me just tell you the answers so that you can check your work in case you finish the problem, right? I don't have, give me just a second. So we would have that beta would be, about 31.99, and little b turns out to be 34.77. You would need to find beta first before you find little b. And then just to recap, this is kind of everything together. Here are your laws of sines and cosines with their correct ratios.